Hi everyone, my name is Young Kim and I'm a PhD student at the University of Southern California. On behalf of my co-authors, I'm pleased to present MemRoPE training-free infinite video generation via evolving memory tokens for ECCV 2026. Long video generation is essential for applications such as autonomous driving simulation, world modeling, and cinematic long takes. These applications require continuous, coherent scenes over minutes or even hours rather than the few second clips. However, current commercial video models typically generate only a few seconds. Their bidirectional diffusion architecture processes all frames together, so longer videos require every frame to remain in GPU memory. This creates a fundamental duration limit. Autoregressive diffusion offers an alternative. Like a language model generating tokens sequentially, it generates video one segment at a time. Each new segment is conditioned on past frames stored in a key value or KV cache. But this introduces two challenges. First, ROP must extrapolate beyond the short temporal range seen during training, causing attention patterns to degrade. Second, the KV cache grows with every frame. At 1 hour, it would need to store tens of thousands of frames. The positional issue can be addressed with relative indexing. Regardless of the absolute time, frames inside the cache always reuse positions within the model's training range, avoiding positional extrapolation. The remaining challenge is memory growth, which requires effective KV cache management. A common solution is FIFO eviction. Remove the oldest frames when the cache is full. But discarding those frames also removes the subject's original appearance and scene context, leading to identity drift and accumulated errors over time. Attention-based compression retains the most highly attended tokens from each frame. However, it has two limitations. First, the compression repeatedly retains these same tokens, reducing the memory diversity. Second, newly added tokens tend to receive high attention scores, causing MemRoPE changes whenever compression occurs and making generation unstable. Our solution MemRoPE uses exponential moving averages to create memory tokens that evolve smoothly without MLOT eviction. Slow updating long-term memory preserves global identity, while faster short-term memory captures a recent motion. The technical difficulty is that averaging ROP-encoded keys does not produce a valid positional representation. We solve this with online ROP. We store position-free keys in the cache and apply ROP when computing attention. The stored keys then can be meaningfully aggregated using EMA. Our fixed size cache combines long-term memory, short-term memory, and recent raw frames. Together, they preserve global context and recent dynamics without increasing memory as the video grows. We evaluated MemRoPE on 1.2.1 using movie gen bench prompts and 6 free bench quality metrics. We compare against the training-free baselines and also conduct a 30-participant user study and VLM-based evaluation with Gemini. At both 120 and 240 seconds, MemRoPE achieves the best overall score. At 240 seconds, it improves the average by 1.85 set points over the base model, while attention-based compression degrades below the baseline. For ultra-long generation, infinite ROP is the only applicable baseline. At 480 seconds, we outperform it by 3.1 points in aesthetic quality and 12.2 points in imaging quality. At 1 hour, MemRoPE still maintains strong performance while the baseline declines substantially. Human and VLM evaluations show the same trend. Users consistently prefer our results across all comparisons, and MemRoPE receives the highest VLM visual stability score of 4.15 out of 5. In this dragon dance example, MemRoPE preserves the subject's appearance throughout the video, while comparing methods progressively degrade. The evaluation confirms that both memories matter. Long-term and short-term memory each improve quality, and combining them performs the best. MemRoPE is also robust to hyperparameters with less than 0.7 average metric variation across all tested settings. In summary, MemRoPE jointly addresses positional extrapolation and memory growth through online ROP and smoothly evolving dual EMA memory. It is training-free, plug-and-play with auto-regressive video bonus, and generates coherent video for up to 1 hour. Thank you for listening.